Every morning, millions of seniors blend it into their breakfast smoothie. They add it to their salads, they juice it, they eat it raw by the handful because every clean eating guide, every wellness influencer, every health magazine told them it was one of the best things they could put in their body. And for many of them, particularly after 60, it is quietly, measurably damaging their kidneys. The vegetable is spinach. And before you click away, I am not telling you that spinach is poison. I am not telling you to never eat it again. What I am telling you is that the way most seniors are eating spinach right now, the quantity, the form, and the completely unguarded daily consumption is creating a specific, well-documented threat to kidney health that almost nobody is talking about. And spinach is not alone. There is an entire category of vegetables, Chinese widely celebrated, universally recommended, present in nearly every Eat Healthy After 60 list, that carry the same hidden risk through the same mechanism. Today I am going to give you the full picture, not to take food away from you, but to give you the information that lets you eat it safely, the way that actually protects your kidneys instead of slowly compromising them. I am a doctor and I am a board-certified physician with a clinical focus on nephrology support, kidney disease prevention, and dietary medicine for older adults. I have spent years working with patients whose kidney function was declining in ways that didn't fit the obvious risk factors. No diabetes, no severe hypertension, no family history of kidney disease. Just a quiet, steady GFR decline that, when traced back carefully, pointed consistently toward dietary patterns nobody had ever questioned. Dietary oxalate, the compound at the center of this conversation, is one of the most underappreciated kidney health factors in clinical medicine. It is not discussed enough in primary care. It is barely mentioned in the standard kidney health conversations most patients have. And yet it is directly implicated in kidney stone formation, tubular cell injury, and a form of kidney damage called oxalate nephropathy that can be severe and irreversible. The reason it doesn't get discussed, partly because the foods involved are universally labelled healthy. Nobody wants to complicate the eat more vegetables message, and partly because the supplement industry, which profits from simple, fear-based narratives and proprietary solutions, has no particular interest in a nuanced conversation about how to eat a vegetable safely. I am not your doctor. Please consult your physician before making any changes to your diet or medical regimen. If you have existing kidney disease, kidney stones, or reduced kidney function, this conversation is especially relevant to have directly with your nephrologist or renal dietitian. What I can give you today is the science, complete, honest, and practically applicable. Before the 5 mechanisms, I need to give you a precise, simple understanding of oxalate, because the fear around it is often either too vague or too extreme, and neither serves you. Oxalate, also called oxalic acid, is a naturally occurring compound produced by plants as a metabolic byproduct. It serves as a defense mechanism, making plants less palatable or digestible to insects and animals. It is present in varying concentrations across a wide range of plant foods. Very high concentrations in spinach, Swiss chard, beet greens, rhubarb, almonds and beets. Moderate concentrations in sweet potatoes, nuts, and certain legumes. Low concentrations in most other vegetables. In the human body, oxalate is absorbed in the gut and travels through the bloodstream to the kidneys, where it is excreted in urine. In a well-hydrated body with adequate calcium intake, most dietary oxalate binds to calcium in the gut before it's even absorbed, forming calcium oxalate complexes that pass through as waste. The kidney never sees them, but when dietary oxalate is consumed in large amounts without adequate calcium, or when fluid intake is low and urine is concentrated, or when gut bacteria that normally help metabolize oxalate are depleted. A far higher proportion of dietary oxalate reaches the kidneys as free oxalate. And free oxalate in the kidney is where the damage begins. Here is why this matters more after 60. Aging changes three things that collectively make the oxalate burden harder to manage. Kidney filtration capacity declines, so the kidneys must work harder to clear the same oxalate load. Gut microbiome diversity decreases, including the population of Oxalobacter formigenes, a bacteria specifically evolved to break down dietary oxalate before it's absorbed. And fluid intake tends to decrease with age as thirst sensation diminishes, concentrating urine and raising the risk of crystal formation. The same spinach salad that was metabolically manageable at 45 becomes a genuinely different kidney challenge at 68. With that foundation clear, here are the 5 mechanisms. Mechanism number 1, the crystal factory, how oxalate builds kidney stones. Let's start with the most widely known mechanism, even if the full picture is rarely explained. When free oxalate reaches the kidney tubules, those tiny tubes where urine is being formed and concentrated, it encounters calcium ions that are present in the tubular fluid. In a concentrated urine environment, which is the norm in mildly dehydrated older adults, oxalate and calcium combine to form calcium oxalate monohydrate crystals, microscopic, sharp-edged crystals that are the building blocks of kidney stones. These crystals do not start as the large stones that cause the excruciating pain most people associate with kidney disease. They start as invisible, microscopic deposits, forming in the tubular lumen, adhering to tubular cell walls, accumulating over months and years. The stone that a patient passes painfully in their 70s was typically growing silently in their 60s. A study from Brigham and Women's Hospital found that high dietary oxalate intake, particularly from spinach and nuts, was associated with a significantly elevated kidney stone recurrence risk, and that adults who consumed more than 250 milligrams of oxalate daily had approximately double the stone formation rate of those consuming under 100 milligrams. For context, a single cup of raw spinach contains approximately 650 milligrams of oxalate. A 2-cup raw spinach salad, entirely normal by current wellness standards, contains over 1,300 milligrams, 13 times the protective threshold, in one meal. The practical countermeasure starts with awareness of that number, and it involves a simple preparation shift I'll describe in detail in the action plan. Mechanism number 2, the tubule destroyer, direct cellular injury from oxalate crystals. This mechanism is less discussed than kidney stones, and more insidious, because it causes damage that doesn't produce dramatic symptoms, doesn't show up on imaging, and progresses without warning until the GFR numbers tell a story that's already years old. When oxalate crystals form inside or adhere to the cells lining the kidney's proximal tubules, the cells responsible for reabsorbing glucose, amino acids, and critical minerals from filtered blood, those crystals physically damage the cell membrane. The crystal's sharp geometry punctures and destabilizes the lipid bilayer. The cell activates inflammatory pathways. It releases reactive oxygen species, no free radicals, that damage neighboring cells. An inflammatory cascade begins. Over time, repeated cycles of crystal formation and inflammatory response produce tubular fibrosis, scarring of the tubule walls. Scarred tubules cannot reabsorb nutrients or concentrate urine properly. Their function is permanently diminished, and unlike most other tissues, kidney tubule cells have very limited regenerative capacity. The damage is largely irreversible. This process, calcium oxalate nephropathy, has been documented in case series and cohort studies as a consequence of chronically high oxalate intake, particularly in the context of the green juice and smoothie culture of recent years. A landmark report in the New England Journal of Medicine documented multiple cases of acute oxalate nephropathy, serious, rapid kidney failure, directly attributable to high oxalate dietary patterns, including daily green smoothies containing multiple large servings of raw spinach and Swiss chard. Several of these patients required dialysis. Some did not recover full kidney function. The critical variable in each case was not that they ate spinach. It was that they consumed it raw, concentrated in large daily quantities, without the calcium pairing that would have bound the oxalate in the gut before it reached the kidneys. Mechanism number 3, the gut connection. How depleted microbiome amplifies oxalate damage. Here is a mechanism that is almost never discussed outside of specialized nephrology literature, and it is particularly urgent for seniors. Your gut contains a bacterium called Oxalobacter formigenes. It lives in the large intestine, and its sole metabolic purpose is the breakdown of dietary oxalate. When this bacteria is present in healthy populations, it can degrade a significant portion of intestinal oxalate before it is absorbed, substantially reducing the oxalate load reaching the kidneys. Adults over 60 have significantly reduced populations of O formigenes compared to younger adults. The reasons are multiple: years of antibiotic use that disrupted the gut microbiome, dietary patterns low in fermented foods and prebiotic fiber that sustain bacterial diversity, and the natural age-related decline in gut microbiome richness. A study published in the Journal of the American Society of Nephrology found that individuals colonized with O formigenes had a 70% lower risk of recurrent kidney stones compared to those without this bacteria, 70%, from a single gut organism, whose population is dramatically reduced in the majority of seniors consuming high oxalate diets without any compensatory protection. This means that the senior eating a daily spinach smoothie is consuming the same raw oxalate as a younger person, but with a gut that is far less equipped to intercept it before it reaches the kidneys. The effective oxalate dose hitting the kidney tubules is substantially higher for the same dietary intake, simply because of age-related gut changes. The practical response has two components. First, support gut microbiome diversity through fermented foods, prebiotic fiber, and diverse plant food consumption. Plain yogurt, kefir, sauerkraut, garlic, oats, and lentils all support the gut environment that beneficial bacteria, including oxalate metabolizing strains, depend on. Second, this makes the calcium pairing strategy even more critical, since the gut's oxalate processing capacity is reduced, and more calcium binding at the intestinal level is needed to compensate. Mechanism number 4, the preparation factor. Why raw versus cooked changes everything. This mechanism is where the fear around spinach and high oxalate vegetables transforms into practical hope, because this is where you get your food back. Cooking dramatically reduces the oxalate content of high oxalate vegetables, not slightly, dramatically, and the specific cooking method matters. When you boil spinach, submerging it in water and applying heat, oxalate leaches out of the plant cells into the cooking water. Studies have shown that boiling spinach and discarding the cooking water reduces its oxalate content by approximately 30 to 87%, depending on the study and the cooking time. The range is wide, but even at the lower end, this is a transformation of kidney risk. Steaming is less effective than boiling for oxalate reduction, approximately 5 to 15% reduction, because the oxalate has nowhere to leach. The water contact is minimal. A study published in the Journal of Agricultural and Food Chemistry measured oxalate content in spinach across multiple preparation methods and found that boiling followed by draining and discarding the cooking water produced the greatest reduction, reducing soluble oxalate by up to 87% compared to raw spinach. A cup of boiled, drained spinach carries a fraction of the kidney risk of a cup of raw spinach. This single fact, boil your spinach, discard the water, is one of the most powerful, most practical and most under-publicized kidney protection tools available to any senior who loves green vegetables. It costs nothing. It takes 5 minutes. And it transforms a high-risk food into a low-risk one. The same principle applies to Swiss chard, beet greens, and other high oxalate leafy vegetables. Boil, drain, discard the water. The vegetables' vitamins, particularly the fat-soluble ones, are largely retained. The oxalate is largely gone. Raw spinach in a salad once a week in a modest portion, manageable for most seniors with good kidney function. Daily raw spinach. Smoothies or large raw salads. A genuine kidney risk that preparation can entirely avoid. Mechanism number 5. The calcium pairing protocol. The one strategy that changes the math. The fifth and final mechanism is not about what spinach does to kidneys. It is about what you can do at the meal level, every time, to prevent the kidney from ever seeing the problematic oxalate in the first place. Calcium binds to oxalate in the gut. When dietary calcium and dietary oxalate are present together in the intestine at the same time, they form insoluble calcium oxalate complexes. They essentially neutralize each other, become unabsorbable, and exit the body as waste. The kidney never encounters them. The entire problem is intercepted before it begins. This is why the research on calcium and kidney stones produces a finding that surprises almost everyone who hears it. Higher dietary calcium intake is associated with lower kidney stone risk, not higher. Despite calcium being a component of the most common kidney stone type, a landmark randomized controlled trial published in the New England Journal of Medicine, one of the most influential studies in kidney stone research, found that a diet high in calcium but reduced in animal protein and salt was more effective at reducing kidney stone recurrence than a traditional low-calcium diet. The dietary calcium was intercepting the oxalate in the gut before it could reach the kidneys. The practical application is beautifully simple. Never eat a high oxalate food without pairing it with a calcium-containing food at the same meal. Not hours later, at the same meal, so the calcium is present in the intestine when the oxalate arrives. A spinach salad with plain, full-fat yogurt dressing, cooked chard alongside a piece of cheese, beets with a glass of kefir, almonds with a small glass of milk, or a calcium-rich seed like sesame. Calcium supplements do not provide this benefit as effectively as dietary calcium. And in fact, calcium supplements taken without food may slightly increase stone risk because the timing doesn't align with meals. Real food calcium, eaten with the high oxalate food, is what intercepts the oxalate at the intestinal level. This pairing strategy, combined with cooking and portion control, means that most seniors can continue eating spinach, Swiss chard, beets, and almonds safely, not in raw, concentrated, unlimited quantities, but as part of a thoughtfully constructed meal. The food is not the enemy. Unguarded, uninformed consumption of it is. Here is everything assembled into a clear, practical daily system. Step 1. Know your high oxalate vegetables. Spinach, Swiss chard, beet greens, rhubarb, and beets are the highest. Almonds are also very high. Awareness is the first protection. Step 2. Cook high oxalate vegetables. Boil spinach and Swiss chard, drain fully, and discard the cooking water. This reduces soluble oxalate by up to 87%. Reserve raw spinach for occasional use in modest portions, not daily and not in large quantities. Step 3. Never eat high oxalate foods without calcium pairing. Plain yogurt, real cheese, kefir, sesame seeds, or calcium-rich legumes eaten at the same meal intercept oxalate in the gut before it reaches the kidneys. Make this pairing automatic and non-negotiable. Step 4. Hydrate adequately every day. Dilute urine is the most fundamental kidney stone prevention tool available. Concentrated urine dramatically increases crystallization risk. Target pale yellow urine throughout the day. 2 to 2.5 liters of water daily minimum. Step 5. Support your gut microbiome. Fermented foods, plain yogurt, kefir, sauerkraut, and prebiotic fiber from garlic, oats, lentils, and diverse plant foods support the gut bacteria that help degrade dietary oxalate before it's absorbed. Step 6. Eliminate the concentrated oxalate sources entirely. Daily green smoothies with multiple large handfuls of raw spinach or chard are the highest risk application of high oxalate vegetables. If you currently make daily green smoothies, substitute with lower oxalate greens, romaine, arugula, kale in moderate amounts, or use cooked and cooled spinach in your smoothie rather than raw. 6 steps, 0 supplements required, all of them based on the same physiology and the same research that nephrologists use when counseling patients with kidney stones and CKD. I want to close with something I genuinely believe. The Eat More Vegetables message is one of the most broadly correct pieces of dietary advice in existence. Vegetables are not the enemy of kidney health. Most of them are actively protective of it. But broad advice applied without specificity, without preparation knowledge, without pairing strategies, can inadvertently cause harm in a population whose kidneys process these foods differently than they did 20 years ago. That is not a reason to stop eating vegetables. It is a reason to eat them with more information. You now have that information. You know which vegetables carry the highest oxalate burden. You know that boiling and discarding the water dramatically reduces that burden. You know that calcium pairing intercepts the problem at the gut level before the kidney ever encounters it. You know that your gut microbiome matters for oxalate management and how to support it. That knowledge changes the risk profile of every green smoothie, every spinach salad, every handful of almonds, not by taking them away, by giving you the tools to consume them safely. If this video gave you something genuinely useful, something that will sit in your mind the next time you prepare a meal, something worth sharing with a senior you love who does a daily green smoothie, please consider subscribing. Every week I bring you this level of specific, honest, clinical information with nothing to sell and everything to share. Next week I am going to cover the 5 most important kidney health lab values that every adult over 60 should track, including the specific number that predicts kidney decline years before standard tests catch it, and exactly how to ask your doctor for it at your next visit. That video could genuinely change your timeline. Until then, cook your spinach, pair it with calcium, drink your water, and give your kidneys the informed environment they have always deserved.